Okay, let's go. So this is the six questions we are doing. Of course, we are still in the paper 2. So let's move on, guys. This is a thermochemistry question. Personally, I love thermochemistry question. Do you know why? Because thermochemistry question always the same thing. They just repeating the same thing, and the formula for thermochemistry always consistent and the same. If you look for thermochemistry questions, the simple calculation will be Q equals to mc theta. You can't change this formula. Okay? For your information, the M stand for the mass, and the C stand for specific heat capacity of water, which is 4.2 joule gram degrees Celsius, and also theta. Some reference book they also put as a delta T, which is referred to whether delta T should be capital letter T, which is stand for the TF minus TI, which is stand for the final temperature minus with the initial temperature. Of course, guys, I'll try to do some recall, guys. I do some recall, then we do the exercise. In this particular question, they always will ask you to calculate the delta H value, the heat of reaction. When we say the heat of reaction will be Q over with mole. Q over with mole. This is a very common one that you need to know. And in this particular question, in thermochemistry as well, if you look thermochemistry, always remember in the thermochemistry, you were going to calculate you need to draw the what do you say, the energy level diagram, or sometimes they might ask you also the energy profile diagram. Okay, of course, when I'm talking about energy level and profile diagram, you must understand that we have a two type of reaction. Okay, you have a two type of reaction, which is you have a endothermic and as well as a exothermic. Okay, from the word itself, endothermic and exothermic, you can notice that endo, they already give you a clue that indicate the heat. Thermic is stand for heat. Therefore, endothermic is actually stand for the heat enter. The heat enter. It is actually from the word of enter, heat enter. On the other hand, exo is from the word of exit. What is exit? Heat, thermic, the heat exit. So, therefore, endothermic, I'm actually absorbing the heat from the surrounding, and exothermic is actually the heat is loose to the surrounding. You must remember this. Yeah? Therefore, when I'm talking about endothermic, the delta H value will be always positive or negative. Tell me. When I say endothermic, very good. It's going to be a positive delta H value. And I have an exothermic. Automatically, you know, if the other side is positive, this side will be a negative value. Okay? And also, they are related to thermic, temperature. If I'm talking about endothermic, I'm absorbing the heat energy from surrounding, the temperature will be increases or decreases. Increase or decreases? It will decreases. Very good. And also the negative value will be the temperature will be increases. Yes. This is a very short revisions on a thermochemistry. You might screen capture this thing. You might screen capture this thing. Okay, done. Okay, I'm gonna erase this. Is Ayman here? Is Ayman here? No. Okay. let's have a look the thermochemistry equation, the diagram. I'm going to teach you how to draw the energy profile diagram. Okay, energy profile diagram. So remember, guy, the word is profile diagram. Always keep in mind, if I'm asking about profile diagram, you need to put the EA. EA stand for activation energy. Activation energy. Okay, so the EA is activation energy. What is activation energy is actually? What do you mean by activation energy? Anyone? Activation energy. Macam mana, girl? Macam salah je. Tapi ayat tu macam dah betul sikit dah. Hurry up. Yep. Uh-huh. I will say, I think I go through this chapter with all of you. When I say activation energy, you must always keep in mind a minimum energy. The keyword, you must mention a minimum energy. So activation energy stands for the minimum amount of energy needed to change the reactant to the product. Again, minimum energy needed needed to change reactant to product. Janganlah salah. You must mention the word of minimum energy. The keyword is over there is the minimum energy needed to change the reactant to product. Reactant to product. Okay? So let's draw the reaction. I'll give you a simple reaction, my dear student. Let's say I do have A plus B give you C plus D. A simple one. Of course, you know AB is the reactant. AB is the reactant. And the CD will be the product. Of course, product, reactant and product. Where in this case, example, just an example, I make it over here 50 kilojoule over mole and 30 kilojoule over mole. Okay. So how to draw the energy? Okay, by looking at this diagram, guys, by looking at this equation, 50 become 30. Exothermic or endothermic? It is exothermic or endothermic. 50 become 30. It is exothermic. Very good. So I'm going to draw an exothermic energy profile diagram. So in this case, you have the y-axis. The y-axis something like this. And you do have energy over here, which is stand for kilojoule over mole. Okay. And on top of it, of course, you will agree with me the 50 is somewhere around here and the 30 is somewhere around here. How to complete the diagram? You just need to draw it accordingly like this, and you go up and go down and straight again. Please guys, during your SPM, you must label a completely. Stand for, you must put it over here, the equation A plus B example and a C plus D. And the AD is the reactant, and the CD will be the product. Okay, and don't forget to label the EA. The EA will be this region, and this is your EA. So this is your energy level diagram. Nevertheless, in certain reference book, For the x-axis, they might put it the x-axis. For personal, they put it as the reaction pathway. The x-axis is reaction pathway. Uh-huh. Can I put the EA outside? Tak, you boleh je letak dengan syarat you labelkan dia lah. You labelkan dia. It shouldn't be a problem. And also, guys, this is EA. Where does the delta H? You must label delta H is the, if you look, delta H is product minus reactant. It's a product minus reactant. Therefore, this is the region. The delta H value. So in this case, the delta H value will be negative 20 kilojoule over mole. Bingo. Please screen capture this thing. Done? Okay, screen capture this thing. I'm going to teach you another diagram. I just do a revisions. I didn't go through the chapter detail because we have learned in the previous. Okay, so just a quick recall. Okay, I'm going to erase this. Okay, now you have a look. Almost a similar question. You have a A plus B and you have a C plus D over here. And here is the 30 kilojoule over mole and 50 kilojoule over mole. Okay, guys, quickly draw the energy profile diagram for me. Quickly draw. I'm specifically asking energy profile diagram. Even though certain reference or certain exercise that you do, they might ask you the energy level diagram. But I put it here specifically profile diagram because I want you to learn where does the EA is actually coming from. So by looking over here, guys, yes, Ryan. Okay, I teach you a bit later the difference between energy level and energy profile. Okay. So guys, by looking at the value, 30 become 50 is an exothermic or endothermic. This is exo or endo. This is endothermic graph. Yeah, very good. It is an endothermic. Okay, very good. So by looking at here, you have this one. This is your energy, which is a kilojoule over mole. And of course, you will agree with me, the 50 is somewhere around here and the 30 is somewhere around here. In this case, of course, you will change the reactant become product. The reactant become product. So this is your reactant and this is your product. So if that is the case, it's gonna be something like this. Go straight, up and down and go straight. So this is endothermic. Of course, the staircase are going upward. Tangga dia naik tangga. Endothermic. Therefore, always remember to label accordingly. This is your A plus B and this is a C plus D. In this case, my dear, this is your reactant and this is your product. Okay, and this will be your delta H value. This will be your delta H value. In addition, the EA will be this much. This is your EA. Okay, just now Ryan asked about the energy level diagram. Okay, guys, let's change this to energy level diagram. So, energy level diagram. Actually, Ryan, it doesn't have much different. Energy level diagram, it doesn't have the EA, that's all. So how to plot the graph is quite simple. You just draw this one, again, label accordingly. Energy will be kilojoule over mole, and the 30 will be somewhere around here, and the 50 is somewhere around here. You drew the same stuff, go straight and straight. Like this. Energy level diagram. Of course, you need to label. This is your A plus B and the C plus D. And this is your energy. This will be your... energy pula. Reactant, Reactant. And this will be your product. And this will be your delta H, which is, in this case, a positive 20 kilojoule over mole. Label over here, positive 20 kilojoule over mole. Okay, this is the difference between energy level diagram and energy profile diagram. Please screen capture this thing. Ryan, understand? Aiman, kenapa lambat? Kau tidur kan? Aku tak peduli. Kau menyanyi sekarang? Kan, okey lah, kau kena buka kamera lah sampai habis kelas. Tak apa, saya report ke dating. Ya, saya text dalam group lah. Okay, screen capture this thing. Okay. Done. Very good. I'm gonna erase this. Jom kita tengok soalannya sekarang. Okay, now we go back to the question. That is just a revision base. Okay. Okay, let's look over here. Diagram 5 shows the apparatus set up to determine the heat of precipitation. Heat of precipitation, in the other word, will be, I can also say, is a double decomposition reaction to produce insoluble salt. So sometimes heat of precipitation, also called as a double decomposition. Double decomposition. Okay, to produce insoluble salt. Okay, guys, whenever you get a chemistry question, don't so excited answering question. Try to understand what is the need of the question, then start to answer. Okay, in this particular question, I noticed I'm using plumbum nitrate. What is the formula of the plumbum nitrate? Of course, PB bracket and O32, plumbum nitrate. Yes. And also I have potassium sulfate. Potassium sulfate will be K2SO4. Both are soluble salt. Both are soluble salt. Why? In the first one, it do have a nitrate. Nitrate are soluble salt. And the second one, it have a potassium. Potassium is a soluble salt. Guys, do you still remember how to memorize the soluble salt? The type of soluble salt? I have teach you no ana. In our previous class, we have go through that no ana. No ana will be always a soluble salt. It's a soluble salt. What do you mean by no ana? Nitrite, ammonium, sodium, potassium. No ana. Whenever you come across with the no ana, it is must. It's a must to form a soluble salt. It is a soluble salt. Okay. In this case, okay, let's look the initial temperature is 28, and it becomes 32. Guys, is there an increase in the temperature? Is there an increase? Yes. When there is an increase in the temperature, therefore, it's an exo or endo? Endo, increase in temperature. It is a exothermic. It is a exothermic. Very good. Therefore, the moment I put the exothermic, you already start to imagine the graph is going upward. That is the main, exothermic, it's going downward, exothermic. So that is a keyword. So you can imagine how the question is going to be. Okay, so you can screen capture whatever that necessary, or you might write it down. A certain clue that you might focus as well, the volume and the concentration. The volume and the concentration. You are lucky enough, the volume and the concentration for both cases are the same. Therefore, what this stand for? This stand for the moles going to be the same. So you are not going to worry about which one you are going to take in the calculation. Let's say I want to calculate the mole, my dear. Of course, I'm going to use the MV over 1000, the formula. Therefore, the M will be 0.5 and the V will be 50 and divide by 1000. Press the calculator for me, my dear. Take out calculator. I think this question is going to involve the calculation. Answer, please. 0.025 mole. Betul ya? Dan? Yes, baby. Based on the temperature. We can differentiate between is exo or endothermic based on the temperature. That's why in the very beginning I asked you, the temperature increases or decreases. When the temperature is increases, automatically it is understood exothermic. When the temperature are decreases, then it is a endothermic. Yeah. The delta H is the different. Got it? Ryan? Okay, Okay, very good. So I'm gonna erase this. Let's go to the question. But guys, before that, let's have a look at the chemical equation. You have a K2SO4 plus PbNO3 2. I love to do this, huh? Okay, you break it down accordingly. K plus SO4 2 minus Pb2 plus and NO3 minus. You're gonna add accordingly. Of course lah. This and this going to mix and this going to mix over here. Okay. So what happened? You're gonna get a PbSO4, which is an insoluble salt that's formed in a solid, plus the KNO3 is still a soluble salt, therefore aqueous. This is aqueous, and this is aqueous as well. Is this balanced? Is this balanced? Is this balanced? Not yet, because it have a 2 potassium over here, and here only have 1 potassium, so you put a 2 over here. So 2, 2, and 1, 1, 2. Okay, I think balance. Yes. Is this balanced? Okay, this is what we call as a chemical equation. This is your chemical equation. Let's change this chemical equation into an ionic equation. So remember, ionic equation is the one, our main focus will be the PbSO4. Therefore, you are going to get PbSO4 solid. So what plus what give you PbSO4? The answer will be Pb2 plus aqueous plus with SO4 2 minus aqueous. So this will be your ionic equation. Please write it down. Oh, you might screen capture this thing. Yes, my dear. The A for ammonium, NH4 plus, ammonium. No Anna. Yeah. Okay. If you done, then I can proceed. Then let's look. Okay. This is a very common question, guys? Very common question. Why you are using a polystyrene cup? Any idea? Why specifically you are using the polystyrene cup? You cannot say to avoid now. It is very difficult to avoid. That is the right word. To reduce. Wait, guys. 1 second. Kejap. This is number 6, am I right? Okay. Okay, jangan tulis to avoid ya. To reduce is acceptable. To reduce heat loss to surrounding. Or maybe you can also use, maybe you can use that a polystyrene cup is a good heat insulator. Polystyrene cup is a good heat insulator. Heat insulator. Okay. Write the ionic equation for the reaction. Mamma mia, we just done this. Then we have a Pb2 plus aqueous, and you plus with the SO4 2 minus, also aqueous because soluble salt, and this will produce a PbSO4 which is insoluble salt. Okay, now look at that. The heat change in the experiment. Okay, so you're going to use Q equals to mc theta. You refer back to the question. So you know what is the total volume, total mass. What is the total mass? If you look over here, my dear, if you look over here, the volume is 50 plus 50. 50 plus 50. Therefore, the total volume or the total mass is equivalent to 100. Therefore, we back to the question over here. Okay, so the total mass will be 100 gram, and the specific heat capacity will be 4.2 joule because it's given gram and degrees Celsius. I know some of you already started calculating. What is the temperature changes? From 28 degrees Celsius, it become how much here? Just now? Still, pardon? 32 degrees Celsius. 32 degrees Celsius. Therefore, 4 degrees Celsius. Good. So press the calculator for me. 1618 joule. 18 or 80, sorry. 80 joule. But change this to kilojoule. So it become 1.68 kilojoule. That's it. Now, they ask us to calculate the heat of precipitation. Delta H, as I told you, is a Q over mole, and the Q you just calculated, 1.68 kilojoule over the mole. You have calculated the mole earlier. What is a mole? 0.0. What is a mole? 25. Okay, 25 mole. And what is the answer? 67, yeah, 67.2 kilojoule over mole, and this is exothermic. You must include the negative over there. But it's quite high lah. Why tinggi sangat eh? Yalah, betul lah tu. You must put the unit and you must put the negative sign. Then you write a sentence, the heat of precipitation. Then you write a sentence, heat of precipitation of a lead 2 sulfate is negative. Oh, siapa tu? Jangan bergaduh. Alisha, jangan bergaduh. Kita ada gaduh, Okay, then you write a sentence, heat of precipitate, PPT, of this thing, PB2, PbSO4. Then write it down lah, negative 67.2 kilojoule over mole. Mesti tulis unit. No unit, they penalize 1 mark. Mesti unit. You must include the unit. Okay, you might screen capture this thing. Done? Okay, I'm going to continue to the next page. Okay. Taran alcohol. Oh, about the heat of combustion, More or less, it's still the same thing going to be happen. Okay. Table 3 shows the value of the heat of combustion for 4 type of alcohol. Okay, blah, 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 blah. What can I notice? I do notice, look at here, from the diagram, I notice the more carbon when I have, because in a carbon compound you have learned add, mat, add, prop, boot, pen, hex, hep, hoc, nut, that. Therefore, the more carbon that you have, the heat of combustion increases as well. Therefore, you have a rough idea. The pentanol definitely going to have a higher value. It might be around 3000 kilojoule over mole. Around. That is the idea that I get from this information. Okay, what do you mean by a heat of combustion? Very common question. They might ask you about the definition of the system itself. What can I say? The definition. Very good. Heat change. Uh-huh. Excess oxygen. But boy, you are right. Lagi. Continue. At the excess oxygen. Continue. Ah, at standard condition. At standard condition. Okay, in this case, you can see they are using alcohol. We can use the word of alcohol over here. Therefore, I can say when 1 mole of alcohol undergo a complete combustion in excess of oxygen at standard condition. Bingo. That's how you do it. Yep. Mm-hmm. Mm-hmm. This is in general only, boy. Your answer also right. If you don't want to use alcohol over here, it's okay. It's okay. You just use when one heat change, when 1 mole of the fuel undergo a complete combustion in an excess of oxygen at standard condition. Betul. Saya je letak alcohol. It shouldn't be a problem for you. If they will ask you specifically, look at the question. Dia akan cakap, define the heat of combustion based on the experiment. If they say based on the experiment, you need to give the definition a bit specific. That is how you should answer the question accordingly. In general. In general. If they didn't ask you specifically, don't answer specifically. Ini pun general. Alkohol ni kan general. Faham tak, boy? Kalau saya letak, let's say in this question, kalau saya letak, when 1 mole of ethanol undergo a complete combustion, saya dapat kusum markah. Sebab I'm too specific. Alcohol is in general. Please keep that in mind. Okay, determine the value of X. Guys, roughly, macam mana nak determine, if you look, around here to here is 600. Betul tak? Tak. 300, am I right? Tak, around 600, sorry, It's around 600. And also, here to here is also around 600. So, in your opinion, here to here will be also 600. Around. Estimate, more or less. So, what will be the X value? Because they asked you to determine the X value. Tell me. 3,200 kalau tambah. 600. I answer 3,300. Make sure you have the unit, girls and boys. Kilojoule over mole. And don't forget the unit, the sign, negative sign. Yes. You scared it will confusing, am I right? Macam negative become positive, am I right? Wait, because they already have the negative over here. That is your main concern, Okay, no need. Sorry, guys, no need. So overlook that thing. I'm overlook that thing. No need to put a negative. Okay, next one, Explain why the heat of combustion of alcohol are different. Of course lah, tadi saya dah bagi dah jawapan. I have give the answer, the very beginning. What caused the changes in the value? Please let me know. Very good. That is the first answer. Very good. Okay, when the number of carbon increase, the atom carbon increase, what happened? Give me a complete sentence. Because it's a 3 marks. It's a 3-mark question. So the first one is right. The number of carbon. Let me change the things. The first thing, number of carbon atom increases. Then what happened next? The more carbon you have, the more carbon dioxide and H2O is formed. under the combustion, am I right? So you have more carbon dioxide and H2O form. And the third point, ialah more carbon, more product. More carbon, more product. When you have more product form, then what happens? Therefore, the third point, I put it on the top here, tak cukup ruang. More heat release during bond formation. Okay. More carbon, more product, more bond formation. That's why it have higher value. More carbon, more product, more heat from air, more bond formation. That's it. Everything is more, more, more. Yes. In question number 2, this one, am I right? Oh, the second one. This is the one. Am I right? Okay, look at here. That is the one of the concern as well. The girl asked me because over here they already give you a negative sign. So it might cause a contradict. If I further put a negative over here, negative and negative 330 example, it become a positive. So we don't want to have that mindset. So we just ignore the negative and just take the value because they just ask the value. Okay, screen capture. That is it compulsory. You did put it. Better you put it. That you put it. That doesn't cause any harm. Because they just will look at the value. If the value is right, then okay. Okay, my dear. So I'm gonna erase and this one. Okay, that is the end of the section A. That is the end of